Have you ever wondered why the solar eclipse, a seemingly ordinary celestial event, holds such significance for scientists across the globe? Well, a solar eclipse occurs when our moon glides between the Earth and the Sun, casting a shadow that briefly turns day into night. Over the centuries, cultures around the world have viewed these events with awe and trepidation, attributing them to supernatural causes or seeing them as ominous signs. Ancient Greeks believed a solar eclipse was a sign of angry gods, while Viking lore suggested that an eclipse occurred when sky wolves chased and caught the sun. In more recent times, some cultures still regard solar eclipses as bad omens. While these beliefs make for fascinating stories, the real significance of solar eclipses lies in their contribution to scientific discoveries. Did you know that the first piece of the solar eclipse's scientific puzzle was the discovery of helium in 1868? This isn't some whimsical fairy tale, but an intriguing chapter in the annals of scientific history. During a total solar eclipse that year, French astronomer Pierre Janssen and English scientist Norman Lockyer observed a bright yellow line in the spectrum of the Sun's atmosphere. This line was unlike anything they had seen before. It didn't match any known elements on Earth, leading to a thrilling conclusion. They had stumbled upon a new element. They named it helium, after Helios, the Greek god of the sun. But here's the kicker. Helium wasn't discovered on Earth until 27 years later, in 1895. A testament to the power of solar eclipses in driving scientific exploration, the discovery of helium lit the path for countless more revelations. This extraordinary discovery was just the beginning of the solar eclipse's contribution to science. The solar eclipse of 1919 played a crucial role in proving Albert Einstein's revolutionary theory of general relativity. The theory, a cornerstone of modern physics, proposed that gravity is caused by the warping of space-time by mass and energy. But how could this be proven? Enter the total solar eclipse. During a solar eclipse, the moon temporarily blocks the sun's glaring light, allowing us to see stars that are usually hidden. In the famous 1919 eclipse, astronomers observed the light of distant stars bending as it passed near the sun. This shift in the star's apparent position was exactly what Einstein's theory predicted. Imagine it this way. The mass of the sun was like a heavy ball placed on a trampoline, distorting the fabric of space-time around it and causing the starlight to follow a curved path. This pivotal moment underscored the solar eclipse's role as a tool for groundbreaking scientific discoveries. Beyond these discoveries, solar eclipses also help us study the effects of the sun on our atmosphere. When the moon slips in front of the sun, the sudden drop in solar radiation leads to a decrease in ionization. Ionization, for those who might not know, is the process by which an atom or a molecule acquires a negative or positive charge by gaining or losing electrons. This process, driven by solar radiation, is crucial to the composition and behavior of our atmosphere. However, during a solar eclipse, this process takes a brief pause. This gives scientists a unique opportunity to study the sun's influence on our atmosphere without the constant interference of ionization. By observing these changes, we are able to gain a deeper understanding of how the sun's radiation shapes the very air we breathe. The solar eclipse, therefore, is a window into understanding the complex interactions between the sun and our planet. Lastly, the solar eclipse helps us decipher the sun's structure and explosive events. The eclipse does more than just present us with a stunning spectacle. It provides an opportunity to observe the sun's elusive corona. This outermost layer of the sun's atmosphere, usually hidden by the sun's intense light, becomes visible during an eclipse. It's here that we see solar wind born. Researchers can delve into the study of how heat and energy from the sun are transferred to this solar wind, a stream of charged particles that flows from the sun into space. This isn't just a matter of scientific curiosity. Solar wind can impact our technology in space, affecting satellites and even our planet's power grids. By understanding these solar winds, we can better prepare for and protect against these potential disturbances. From ancient superstitions to modern scientific discoveries, the solar eclipse is a rare and special event that continues to intrigue and educate us.